In today's notes, we'll be covering lines of symmetry, central angles, and similar polygons. Lines of symmetry we've already talked about a bit, but it just basically says here that they are going to be lines that bisect. Remember, that means to cut in half equally a polygon, and that they are going to create congruent sides that can be mapped onto each other. So think of it like folding it in half. In doing so, then they land right on top of each other like a hot dog bun. So we get lucky when we talk about regular polygons, because for regular polygons, the lines of symmetry is going to be equal to the number of sides that it has. So we know in an equilateral triangle, we're going to end up with 3 congruent sides. And those 3 congruent sides, of course, we end up with 3 lines of symmetry. We also end up with 4 congruent sides in the square. We know that a square is regular. All the angles are the same. All of the sides are the same. And of course, we talked about this already for polygons. And again, we do end up with, of course, 4 lines of symmetry. And in this one here, with our pentagon, again, we end up with 5 lines of symmetry. And then, of course, with our hexagon, we end up with 6 lines of symmetry, 6 sides that are congruent, 6 angles that are congruent. So just wanted to talk about that one more time before moving on, although we've seen it already. So sometimes we're going to be asked, what is the angle of rotation about the center that will map a regular hexagon onto itself? So again, we get lucky in this case is that when we turn it, because they're talking about rotation, so we know rotation is a turn. When we turn this, we want it to land right back on top of itself. And the way we're going to do this is first by finding the central angle. So that's very easy to do. The central angle is just simply going to be 360 divided by the number of sides. So in this case, the 360 degrees, when I talk about the central angle, this is what it looks like. I'm just going to draw it here. Now, this won't be our last time talking about central angles, but this will be pretty much the gist of it for right now, and then we'll come back to it. So what the central angle is all of these angles right here in the middle. These are what we call our central angles, okay? And of course, what happens here is, as you see those dots, I can just make a circle around all of these. All of these, of course, will be congruent to one another, and that's probably the worst circle that I've made today. It's probably the only circle I made today. So we will do the 360 degrees. And remember, n, from when we studied polygons, was our number of sides. So n equals our number of sides. And of course, we know in a hexagon, our number of sides, of course, would be 6. And just doing some simple mathematics of just doing the 360 divided by 6, we get very lucky here, and we end up with, of course, 60 degrees. So that's step 1. So I know that all of these angles in here are going to be 60 degrees. Now, there's really no need for you to fill it in, but as you guys already know, you know me, you know that I'm going to do that, okay? So 60 degrees. So how do I know what's happening here? Each time I spin this, or each time I rotate this, it should land right on top of itself. And what that means is each 60-degree turn that I make will land this on top of itself. I did not provide my example with me, so I'm sorry there, but we'll perhaps come back to that once I finish this. So now what's going to end up happening for us to select our answer choice here is that we're just going to divide each of our answer choices by this central angle, because any multiple of a central angle will map the shape back onto itself. So what we're looking for is a whole number, So each of these are going to be divided by 60. And we want to do this just in case there are multiple answers. You're probably already thinking to yourself, like normal, I already know what the answer is. And possibly because, of course, it's a pretty easy outcome. We know that this would take us here 3.5, which is not, 3.15, which is not going to be even. We'll go ahead and divide the next one and see how many rotations. So this is what this is. How many rotations? It has to be complete rotations for it to map back onto itself. So we'll take that 480 and divide by the 60, which was our central angle. And we get 8. So this was 8 rotations. And then this is, I'm just going to put, rotations. So we'll divide the next one, and of course I'm sure you already know that that's not going to work, but we're still going to do it so that we can see what it is. That's important. And then of course the last one. Rotations. So remember, only the ones that are going to make a complete rotation will be the one in which we can select. So in this case, we know that we have 8 complete rotations here for 480 degrees. So this would be our only answer choice, our only viable answer choice for this one. We do the same thing no matter what it was. If it was 360, would it work? Of course it would, because of course 60 divided into 360 would give us 6. So any multiple of that. What if it was 120? Well, 120 would give us 2 rotations, 60 divided into 120. And in that case, of course, it would also work out. So it just depends on if it can evenly be divided in and give us a complete rotation. These rotations are not complete, so they will not turn back onto itself. Okay? All right, I was just about to say any questions, but I am not in class, so I can't answer them even if you do have them. All right, y'all. So similar polygons. Hint, hint, you need to make sure that you know this whole entire phrase. Again, hint, hint, you need to make sure that you know this whole entire phrase. Now, it's not as hard as it looks. It says if 2 polygons are similar, then the corresponding sides must be proportional, okay? And then the corresponding angles must be congruent. So I provided a picture here for you so that you can see just that, okay? In this particular one, we know that polygon A, B, C, D is going to be not congruent, but similar. And what we use for similar is this little squiggly line like that. And it's going to be similar. We want to go in the same order. So we started off with A here. If you notice, W is the same angle measurement. So we'll start off with W, X, Y, and Z, just like we did there. Okay, remember it says that if the polygons are similar, the corresponding sides are going to be what we call proportional. Please don't get lost in the sauce about proportional. Proportional just means the exact same thing as like our scale factor. Okay, so our scale factor when we were dealing with our dilations is what our proportion will be. Okay, if I started off with ABC being our pre-image, and then taking this to WXYZ as our image, then I know that from here to here it would be a dilation. And remember, in this case it goes from smaller to larger, so we're going to have an enlargement. Okay, a simple way for me to find the proportion is for me to take one of the sides, one of the similar sides. Okay, so what I'm going to do is I'm going to look at side AD, and AD is definitely similar to WZ. Okay, those two are similar. All right, so what am I going to do? Remember, we talk about how to put this and solve for it if we were looking for our scale factor, right? So I'm going to go ahead and label this pre-image, and I'm going to label this the image. And I believe when we talked about finding the scale factor, I told you that the image needed to be on top and the pre-image on the bottom. Okay, so in this case what we're going to have, I'm just going to write it out, is the image on the top and the pre-image below. Alright, so again the image was WZ, this is the side we're going to use, over AD. We're going to replace that with the number values, and of course the number value is 9, and the number value here is 3 centimeters. A simple division, 3 divided into 9, of course, is going to give me 3. So my scale factor, or my proportion, is going to be 3. Okay, so I know I multiplied each side by 3. 5 times 3, 15. 6 times 3, 18. 4 times 3, 12. And that gives me the larger shape. So see how that's not anything difficult to remember. Now here is where you have to make sure you don't get lost in the sauce. It says that the corresponding angles must be congruent. And when we look at this, we do see that that is indeed the case. We see that angle A has the same measurement as angle W, meaning that they are congruent. Okay, so angle A, is congruent to angle W. And when we go right on around, we see that B also has the same measurement as X. So I know that angle B is congruent to angle X, and so forth and so on. Now here, when we go down to C, we want to make sure that we line everything up correctly, because we end up with 2 down there at the bottom that actually has the 90-degree markings. Okay, but we want to go in the same order. So as I went up and then down to get to C, I still need to go up and go down to get to Y. I am not using the point vertex point method in naming the angle. I could, but I chose not to. Has to save a little time here. So we see that they are congruent, which is exactly what it says. The corresponding angles, angle A corresponds to W, they are indeed congruent. Okay? All right, I think that's good there. Hopefully this picture, there was no work really that we did other than finding the proportion. And let me just highlight that as our scale factor. Or proportion. Okay, what is going on there? Sorry. My goodness gracious. So scale factor, our proportion, do a better job than me in writing that down. So last but not least, I want to actually do a problem that utilizes similar polygons, okay? So what kind of polygons in this problem? The polygons in this problem is going to be rectangles. So we'll talk about rectangles. I'm just going to pull the sheet down so that I can still leave this here and then work on the paper below. So depending on how you have your notes, if you pick up these notes from the classroom, there'll be room on the paper. If you're printing this at home, you're only going to be left with just this little bit at the bottom. Either force it here or include it in your journal, whichever one you want to do. So it says Jill Scott's closet is rectangular with dimensions of 81 feet by 120. She is planning to use part of the closet for all of her golden shoes. It would be a similar rectangle using a scale factor of 1/3. We want to know how much plexiglass will she need to enclose her shoes on all 4 sides. Now, normally I would draw a rectangle inside a rectangle, but I am not today. As a matter of fact, I take that back. I am going to do just that and then separate them because it's on the inside. So here I'm just going to make what in my mind looks like Jill Scott's closet. Okay, and what I know for sure is that up at the top, that's 81. And I'm just going to write 81 here. And over here to the side, I'm going to write 120. Now, does it matter which one is which? Not really, but what I was trying to get at or make sure that we have is the longer side that I drew actually represented the 120. If you drew it in a different kind of way, that's cool. There's no pressure there. Now, remember this, she says part of the closet, so because this is part of the closet, it's going to be on the inside. And we know that the scale factor is about 1/3. So, do I really know what 1/3 of this is? But I think that's pretty good, y'all. So here's going to be the golden shoes, all right? Everything else is going to be her closet. This is just for the golden shoes. So I'm going to separate these two and write it again. Okay, so I know that the big closet, of course, has the dimensions of the 120 feet by the 81 feet, right? And then I know the little piece here is going to be 1/3. We already know that this is a deduction based off of our scale factor. So we already know that this is, I said deduction, reduction is what it is in a book. So it is getting smaller. So all I have to do to figure out what the, get this y'all, similar sides are going to be is all I need to do is multiply it by the scale factor. So I know that this side is going to be similar to this side. See how I put the little similar markings there? So all I'm doing is taking this and multiplying it by 1/3. Now I'm going to do the mathematics here. Although at this point you could probably just put it into the calculator. Remember, underneath every whole number is an invisible 1. When I multiply straight across, I'm going to get 120, and when I multiply straight across, I get 3. Remember, when we have the multiplication here, you multiply across. If that was an equal sign, then you hit that bad boy up with a cross multiplication. Okay? So the final thing we need to do is divide the 3 into the 120, and of course, when doing so, we end up with 40. Okay, so I know that this side is going to be 40 feet. Okay, this is a ginormous closet and she has a lot of golden shoes. I need to do the same thing here. And I'm going to put 2 little squiggly marks here to represent that these two are going to be the ones that are similar to each other. Again, I'm going to hit that up with an 81 times 1/3. And of course, I'm going to put the multiplication, put that 1 underneath. And of course, in doing so, we end up with 81 divided by 3, and that should give us what's that? We got 6. So 6 goes into there with a remainder of 2. 21, 3 divided into 21 gives us 7. So we know we have 27 feet down here. Okay. Now this is where we got to be careful. Now we would say, hey, this is fine and we've got everything we need, but it's talking about all 4 sides. And whenever we talk about all 4 sides or all the way around, we know we need the perimeter. Okay, that perimeter, all we need to do is add up all 4 sides. So I'm going to just write it down so that you can see it. Of course, in your mind, you probably already got it together. So we're doing 40 plus 40 plus 27 plus 27. And then that's going to, of course, give us our answer. Now, could you have done 40 times 2 and then added that on to the 27 times 2? You certainly could have. Either way, it's fine and it doesn't really matter. You're still going to get the same exact answer no matter what. Which should be 134 feet. Okay. Y'all, I don't really mind how you set this up. As long as you set this up correctly. If you remember that the only thing you needed to do here was divide this by 3, divide this by 3 to get your 40, then that's fine. But you guys know that I'm going to work all of the work out. Please make sure that you have these notes completed and inserted into your journal, taped down. There's nothing on the back of this, so once you finish this side, you are done. Thank you so very much and see you soon.